Okay, we're going to go ahead and continue with the Honors Pre-Calculus B semester exam review, and we're going to start off with number 53. It says a vector in space has an initial point A of -2, -3, 4, and a terminal point, meaning we go from A to B of this. Part A says, what is the component form of AB? So since I'm going from A to B, this is going to be equal to the components of B minus the components of A. Okay, so in the end I will get -1 minus -2 is 1, 4 minus -3 is 7, and -5 minus 4 is -9. So here is AB, that's part A. Part B says, what is the magnitude of AB? So we just plug it into our formula. Okay, which turned out to be square root of 131, which if you round it, let's see, it doesn't say what you have to round to, so I'm just going to say 11.446. Okay, so there's part B. Let's move on to number 54. So we're continuing with our problems on vectors. So it gives us this vector -4, 1, 5, and the vector v, which is -3, 2, -1. Okay. So we are in 3 dimensions again, just like the previous problem. Determine the angle between the vectors the nearest 10th degree. So that is going to be using this formula, which is given to you. So the dot product of u and v divided by the magnitude of u times the magnitude of v. Take cosine inverse of that. So I need to find u dot v first. And so we're going to have -4 times -3. I'm multiplying component by corresponding components. Okay, so I get 12 plus 2 minus 5, which is 9. Okay, so this is going to equal cosine inverse of 9 over, now I need to find the magnitude of u. Okay, and when you do all this, you get square root of 42. Magnitude of v, same process. You get square root of 14. Okay, and when you put all of this in your calculator, be careful how you do that. You usually don't want to do it all at once. Rounding to the nearest, let's see, nearest 10th of a degree, you will get 68.2 degrees. Okay, so that is part A there, the angle between the two vectors. Let's continue with part B. Determine the cross product of the vectors and state the geometric meaning of your answer. So we want to find u cross v. So I'm going to set up my cross product matrix, if you will, or matrix, with the standard unit vectors. Remember that I, just as a quick review, is 1, 0, 0. J is 0, 1, 0. And these are called standard unit vectors because they are all magnitudes of 1. Okay, and they're standard, they're kind of like the very basic of the basic vectors with magnitudes of 1, making them unit vectors. Okay, so just keep this in mind if you didn't remember that. Okay. So I'm going to put u here and v right below that. Okay. So this is going to be equal to I times the following. So what I like to do is, if I'm dealing with I cover up this column in this row that has to do with I, and this little square is what I'm left with. So I'm going to do 1 times -1 minus 2 times 5. Okay, and this is always minus here, so remember that. Next, I'm going to do minus j, so that's the one part you have to remember. The j is a minus, okay? Cover the column of j and the row with j, so I have -4 times -1 minus -3 times 5. Okay, and then I'm going to go back to plus, and I have plus k. And now I do the same thing. I cover this row and this column that have to do with k. So I have -4 times 2 minus -3 times 1. Okay, so if you simplify this, you will get -1 minus 10, which is -11, -11i. Then you will get 4 minus -15. In other words, 4 plus 15, which is 19, but I have a minus out here, so it becomes minus 19j. And lastly, I have -8 minus -3, which is -8 plus 3, which is -5. Okay, and then you can also write this as follows. Now, one thing I did want to make a note of is the answer key does have a slight error. The answer key says that this is positive 19, but it indeed should be -19, so this is correct. Okay, so just be aware of that. Your answer key does have a typo. So the correct answer is -19, but your answer key has a typo that says positive 19. Okay, let's keep going with part C. Write the vector equation of a line that is parallel to you and passes through the point, P, which is 2, 4, -3. So I'm just going to call this S. You can call it whatever letter you want, just to give it a name. Write the vector equation of the line that is parallel to you, and it has to go through the point 2, 4, -3. So I definitely need to include that in my equation because I have to go through that point. That's one of the requirements. And then I'm going to say plus t times the vector that I want to go parallel to, which is u. So u was -4, 1, 5. So what this does is it guarantees that I go through this point because I'm including that, and then it goes in the same direction of u. Okay, and then you can simplify it from there. So you have 2 minus 4t, 4 plus 1t. So what I'm doing here is just combining these. Okay, and then -3 plus 5t. Okay, and I'm fine with leaving my answer like that, so I'm actually just going to leave it like that. I think your answer key has a few other ways to write it, but this is good enough for me, so that's what I'm going to leave it as. Okay, so there's part C. Let's continue on with number 55. A pilot sets his plane to travel due west at 400 miles per hour. A wind is blowing towards the northwest at 60 miles an hour. That blows the plane off course. So the thing I like to do first with these is create a picture. Make that a little bit nicer. Okay, so the plane is traveling due west. Okay, let me make this a different color. So due west, this is the plane. We'll give it P, the vector P. And a wind is blowing towards the northwest. So let's make this maybe blue. So northwest is exactly 45 degrees between north and west. Okay, so what I'm going to do here is I'm going to first come up with vectors for P and W. So the plane vector is actually very easy. You're just going left 400. Okay, so the magnitude, if you go back and look in your notes, the formulas that I'm actually using are the magnitude of P, so this is whatever vector you're talking about, times cosine of the angle plus the magnitude, whoops, comma, magnitude of P times sine of the angle, okay? So this is kind of like the general format. So here it turns out that the magnitude of P is 400, and then cosine of what will be 180 will make it negative 400, okay? And then sine of 180, this will turn out to be 0, so you don't actually need to use this for this one, but you will get the same thing if you do. The next one, the wind. The magnitude of the wind, they say, let's see, is 60 miles an hour. And if you look here, the angle for the wind is actually here, okay? So it's 45 degrees between west and north, but you have this additional 90 degrees here, okay? So northwest is going to be 135 degrees. And then you do the same thing but sine. Okay, and just to make lives a little bit easier, let's write this as decimals. So this is negative 42.43. This is positive 42.43. Okay. So what they say is, what is the ground speed of the plane corrected 3 decimal places? That's part A. So what I need to do first is I need to combine the effects of the wind and the plane. So I'm going to add them component-wise. So I have negative 400 plus this guy is negative 442.43, comma, and then 0 plus 42.43 is still just 42.43. Okay. But what they want is not just the vector of them combined, but they want the magnitude of that vector, and that'll give you the answer for part A. So part A, I'm finding the magnitude of P plus W. So using this vector that I have down here, I'm going to find the magnitude of that up here. This is going to be equal to the square root of negative 442.43 squared plus 42.43 squared. Get rid of this little dot here. And this turns out to be 444.46 miles per hour is the units we're looking at. So that's part A. Okay, part B, in which direction is the plane traveling corrected 3 decimal places? So I'm going to say part B, I'm going to use this formula again. This is a pretty useful formula. Okay, noting that this is quadrant 1. But if I look at P plus W, which I'm basing all of my answers on right now, this guy right here is quadrant 2. Okay, so the rule is I'm going to have to do 180 minus theta. Okay, so this is going to be tangent inverse. Again, using the P plus W vector, 442.43 over 42.43. Okay, which is going to give me 5.478 degrees, but that's a quadrant 1 angle. I want it to be quadrant 2, so I need to do 180 degrees minus 5.478 degrees, which is 174.52 degrees. Now this answer is based off of the east line. So from here, if I go 174.52, I'll find the vector over here. Okay. The answer key, I believe, writes it as, which is kind of a little bit more confusing, but they say 5.478 degrees north of west. I believe that's the wording they use. Okay, so it means the same thing. If you notice, what they're saying is just take this angle and go 5.478 degrees from west, go up here. So from here, go up here, which is the same thing as just going over here. So you end up at the same spot, okay? So you can write it either way, really. Okay, so that is number 55, part A and B. Okay, let's continue with 56. Write the equivalent rectangular coordinates for each point in polar form. These are actually very easy, as long as you know the conversion formulas. So The formulas you want to know are x is r cosine of theta, y is r sine of theta. So if this is r and this is theta, I literally just plug them in. Okay. So this will give me 8 times 1/2, which is 4. This will give me 8 times square root of 3 over 2, which is 4 root 3. So my answer is 4 comma 4 root 3. Okay, these are Cartesian, which is what they want. Okay, or rectangular. Rectangular, Cartesian refer to the same thing. Okay, and then real quick, 57, same idea. Now, if you notice, negative 7 pi over 4 is a negative angle. This is equivalent to negative 4 comma pi over 4. So a coterminal angle of negative 7 pi over 4, okay, which is actually quadrant 1, is pi over 4. So these are coterminal. Okay, so I'm going to say x is negative 4 cosine of pi over 4, just because pi over 4 is more familiar to us. I'm going to do the same thing with sine. This is negative 4 times root 2 over 2. This is negative 2 root 2. This is negative 4 times root 2 over 2, which is negative 2 root 2. Okay, so my answer is negative 2 root 2 and negative 2 root 2. Okay, so that is number 57, and we will continue on to the next page in the next session.